This is talking about the nth term test. The rules at the top talk about that you take the limit to infinity, and if you do not get 0, then this series diverges. This is a easy one to start with, and almost always the first one you're going to do when you start talking about limits. So the first example here we're going to use is determine if the following series converges or diverges. This part right here is a sub n, and so you're going to determine if that goes to infinity. So when you take the limit as n goes to infinity of 2n plus 3, that's a plus, over 3n minus 5, hopefully you remember your limits well enough, going to infinity, and so you look at leading coefficient over leading coefficient when the degrees are the same and these are the same, so the limit goes to 2/3. That is an easy one, and it is not 0, so it diverges. So you would say 2/3 does not equal to 0, so it diverges by nth term test. You need to show the rules whenever you do these. The next one that we're looking at, we're going to do a very similar thing. We're going to take the limit as n goes to infinity. This time we're looking at 3 to the n over 3 to the n. These will grow the same. Sometimes it's really hard to remember that the coefficients right here hardly matter when we're talking about something as big as infinity, because this is going to be 3 to the n over 3 to n. As you get to infinity, these are really big numbers, this part right here, and so the 2 hardly matters. So this is actually, does go to infinity, and this actually is 1. Because it's the same as leading over leading, and they are the same power. So this one also diverges because the limit to infinity is not 0. It's not equal to 0. And it's also by the nth term test. Again, very fast and easy to do these. This last example, we're going to take the limit as n goes to infinity and then the cosine of pi over 3 is 1/2, so that's 1/2 to the n. When you take n to infinity, that makes this a very 1/2 to a large number, but this is a fraction, and so as this part gets you raise it to a larger and larger power, this gets closer and closer and closer to 0. So this limit actually equals 0. At this point, it is inconclusive. I have a lot of students that try to tell me because it is 0 that makes it convergent. That is incorrect. It is inconclusive, and you will need to try another test. When you learn your other tests, you will find that this test works best with geometric. It can converge, but we don't know that yet, so you'll need to use the geometric test to actually simplify this. But the nth term test is inconclusive, and that's where we're going to stop for now.